We now begin studying polynomial and rational functions, and we do so by reviewing complex numbers. So a complex number is a number of the form z equals a plus bi. I squared is defined to be minus 1, and a and b are real numbers. The number a is called the real part of the complex number, which is denoted as such. The number b is called the imaginary part of the complex number, and it is denoted as such. Now, complex numbers can be plotted on what's called the complex plane, which consists of a real axis and an imaginary axis. The real axis is the horizontal axis. The imaginary axis is the vertical axis, as shown here. So what we do when we plot a point is we look at the real part. Let's say it's here. Then we go to the imaginary part. Let's just say maybe it's up here. Right? So this will be our imaginary number, and represent it as a directed line segment from the origin to the point. So that would be our real number here. So let z equal a plus bi be a complex number. The complex conjugate of z, which is denoted here, which is read z bar, is defined as a minus bi. So the complex conjugate of a complex number, you just flip the sign that's attached to the imaginary part. Now, just like with real numbers, we can perform base arithmetic operations on complex numbers. So if you add two complex numbers, you just add the corresponding components. So you add the two real parts and you add the imaginary parts. Same thing with subtraction. You just subtract the real parts and subtract the imaginary parts. If you're multiplying a real number and a complex number, this just works like algebraic distribution. You multiply the real part by the real number, and then you multiply the imaginary part by the real number. When you multiply two complex numbers, this works like foiling in algebra. So you'd have ax, then you'd have ayi, then you'd have bxi, and then you'd have bi times yi, but since I squared is minus 1, it becomes negative by. When you divide real numbers, this works much like rationalizing in algebra. You multiply both the numerator and the denominator by the complex conjugate of the denominator. Then it becomes two complex multiplication problems. Now, there is no need to memorize these formulas. As long as you do the work out for each problem, you'll get the correct answer. So let's look at now applying arithmetic to complex numbers. We'll start by adding these two numbers here. So what we do, remember, is we add the corresponding components. So for the real parts, we have 3 plus 2. For the imaginary part, we have negative 4 plus 5. And so this is 5 plus I. Okay. For subtraction, it's the same thing. So let's subtract the two real parts. So we get 2 minus 3. And the imaginary part will have 5 minus negative 4. And so we get negative 1 plus 9i. And so we're going to do a real number times a complex number. So remember, for this, all we do is we multiply each component by the real scalar. So it'll be 4 times 2 for the real part plus now 4 times 5 for the imaginary part. And so it's 8 plus 20i. Now let's multiply two complex numbers together. So remember, this works much like foiling. So I have 4 times 2 plus 4 times negative 5i plus 3i times 2 plus 3i times negative 5i. Right, so we'll have 8 minus 20i plus 6i minus 15i squared. So we have 8 minus 20 plus 6 is minus 14. Then we have minus 15 times I squared, and I squared, remember, is minus 1. So this actually becomes 8 plus 15, which is 23, minus 14i. Okay. So next, we'll divide two complex numbers. So first, we write this as a fraction, so it'll be 2 plus 5i over 4 minus I. And now what we do is we multiply numerator and denominator by the conjugate of 4 minus I. So now the numerator becomes 2 plus 5i times the conjugate of 4 minus I is 4 plus I, and then over 4 minus I times 4 plus I. So now for the numerator, we're going to have 2 to 4 is 8. 2 times I is plus 2i. 5i times 4 is plus 20i. And then plus 5i squared all over. 4 times 4 is 16. 4 times I is plus 4i. Negative I times 4 is negative 4i. And then minus I plus I times plus I is minus I squared. So we're going to have 8 plus 22i minus 5 over 16. These will drop out. Minus negative 1 is plus 1. So we have 8 minus 5 is 3 plus 22i all over 16 plus 1 is 17. Right? So this will equal 3 over 17 plus 22 over 17i. Okay. We can also evaluate a function at a complex number. So let's evaluate f of x equals x squared minus 5x plus 2 at 3 plus I. So this works in the same way as if we were evaluating f at a real number. All we do is every we see an x, we place it with 3 plus I. Minus 5 times 3 plus I, and then plus 2. Now this 3 plus I squared is the same as saying 3 plus I times 3 plus I, and I'll leave the rest of it the same. Okay, now let's actually go out and do the complex arithmetic. So we'll have 3 times 3 is 9. Then we have 3I plus 3I, which is plus 6I, plus I squared. Then we'll have minus 15 minus 5I, and then that plus 2 still floating around. I squared is minus 1, so we have 8 plus 6I minus 15 minus 5I plus 2. Now it's just a matter of cutting all of our like terms. So 8 plus 2 is 10, minus 15 is negative 5. Then we have 6I minus 5I is just plus I. And so f evaluated at 3 plus I is simply negative 5 plus I. All right, let's now evaluate the function 2 plus x over x plus 3 at 10i. So f of 10i is equal to 2 plus 10i over 10i plus 3. So we have to simplify this. We're not allowed to keep a complex number in the denominator. So multiply numerator and denominator by the complex conjugate. So the numerator will become 2 plus 10i times negative 10i plus 3. Right? Remember, complex conjugate, you make the imaginary part negative, you flip its sign. Then we'll have over 10i plus 3 times negative 10i plus 3. Okay? So we'll have negative 20i plus 6 minus 100i squared plus 30i in our numerator. The denominator, we will have negative 100i squared plus 30i minus 30i, and then plus 9. So in the numerator, we're going to have a 6 squared is negative 1, so this becomes 6 plus 100, which is 106. Negative 20i plus 30i is plus 10i. Then in the denominator, the 30i's will drop out. Negative 100i squared again is 100. So in the denominator we have 109. So we wind up with 106 over 109 plus 10 over 109. Now we can also simplify I to different powers. So let's simplify I to the 35th power. So the idea here is to try and make the exponent even. Well, we can write I to the 35th as I to the 34th plus 1. Now we can use properties. So this becomes I to the 34th times I to the first power. Now what we want to do is we're going to take this even exponent and write it as I 2 times something. Well, in this case, 34 is 2 times 17. And now again, we can use properties, so this becomes I squared to the 17th power, and then times I. Well, now we know what I squared is. I squared is negative 1. Now negative 1 to an odd power is negative 1, so this simplifies as negative I. And that will conclude our review of complex numbers.